So we finished before the topic of line drawing and midpoint circle algorithm, and I have also uploaded the assignment. And at the end of the lecture, I will discuss about the assignment, how to do. Okay, so I hope you have seen the assignment about line drawing algorithms and the algorithm about midpoint circle. Okay, so we will discuss that inshallah. Now the topic of line drawing and circle drawing, it is closed, finished. Today we start new topic which is about OpenGL. Okay, and that is very important topic. This is a programming topic. If you understand the concepts we used in Canvas, if yes, the chapter is the screen. Oh, you don't see the screen? Screen is off on, but chapter is not. The slides are not there, huh? Okay, let me try again. Okay. Do you see them? Yes. Yes, okay, good. So we start the new topic of OpenGL. Okay, this is a programming language topic. We did some programming in JavaScript using Canvas. Okay, but Canvas is not very good. It is not very fast, and it cannot be done, I would say for complicated tasks, okay, for advanced things like game making, good game making. So we discuss OpenGL. Now, what is OpenGL? It is a computer graphics rendering API, and we already know what is rendering. Does anyone remember what is rendering? Rendering means to display on the screen, okay, display a model on the screen. So what we did, we first created a model, or here we will create a model. Okay, it can be a rectangle, it can be a circle, it can be some lines. Okay, so we will draw those in the memory, and then we will render them on the screen. Now in case of Canvas, when we draw something, it is automatically rendered immediately. Okay, you don't actually wait for rendering, or you don't need to do another command or something else to render that. The Canvas API does that for you automatically, but in OpenGL it's not like that. First we will develop a model, whatever model it is, in different ways. We will see them, okay, and then we will render the model on the screen. So there is a command for that to render, and OpenGL is basically used in rendering. Now why is rendering so difficult? Because we will see it becomes a problem in 3D graphics. Okay, in 3D graphics, because you have something which is hidden in the screen, for example, we will see, so you don't show them, and we will understand these soon inshallah. So with OpenGL you can generate high quality color images by rendering with geometric primitives. We will study some primitives. The primitives are points and lines and triangles and rectangles, etc. OpenGL forms the basis of many interactive applications that include 3D graphics. So OpenGL can be used for drawing 2D color images, or drawing 3D graphics, as well as interactive applications. What are interactive applications? Games, even movies you can make with OpenGL. By using OpenGL, the graphics part of your application can be operating system independent, Windows system independent. Now it means that we can use OpenGL in which operating system? In Windows, in Linux, okay, in Mac. Also in Linux, for example, there are different Windows systems. Even in Mac, different Windows systems. So you can use it on any Windows system. Now Windows system does not mean Microsoft Windows. It is a graphical interface system, and there are different things like Genome, KDD, okay, and XFCE. They are different Windows systems, so OpenGL can be used with all of them. Okay, so this is actually a library, and library means there are a set of functions, there are some variables or attributes, and you use them in your code. Okay, now the library in general is available for C, C++, but there are also implementation for Python and Java, maybe C Sharp. Okay, the most robust, the most developed library is that of C and C++. So we will be using that. Now in that library we have different functions which may start with GL or GLU or GLUT. Okay, so a function, for example, will GL begin or GL end or GL load identity. So that's one type of function. Another type of function is GLUT, GLUT init, GLUT create window, and then the third one is GLU, GLU main loop. This is main loop actually, not main loop, and GLU display func. So these are the functions that we use in OpenGL, and because of the GL, we will understand that they are OpenGL functions. Now there are also constants. You know about constant, a fixed value, okay, in OpenGL. So we have all constants in capital letters, and they begin with GL underscore. Okay, so for example, GL underscore 2D means you want to use 2D environment, or GL underscore 3D means you want to use 3D. GL underscore RGB means you want to use the RG and B color. There is RGBA and there may be other color systems, and then if you want to use GL polygon, GL lines, etc. So these are the constants, and they have this abbreviation or names as capital letters. Now when you draw in OpenGL, so there are different ways to draw. The simplest and easiest way is to draw geometric primitives, and that is using GL begin and GL end. Now remember, we did the same thing in Canvas. Okay, we had begin path and close path. Here we have GL begin and GL end. So there was close, here we have end. This is small difference, you need to remember that. And between GL begin and GL end, you are going to write the code. So for example, in Canvas we had GL begin path, then we had the move to, then line to, then arc to, etc. Okay, and then at the end we had stroke, context.stroke or context.fill, and then we will say close path. Here we will start with begin and then use different functions. So the first one is how to define a vertex. A vertex means a point. Okay, so the function for that is GL vertex. Okay, so a vertex is a location in the form of XY for 2D or XYZ for 3D. And using GL begin, GL end, we can draw vertex or points, lines, triangles, and polygons. So these are different shapes that we can draw with OpenGL, starting from basic points. Now we have given these points the names of V1, V2, V3, etc. Okay, just for identification. But when we draw on the screen, there will be no names, there will be just the points. Similarly for independent lines, they are independent because every couple, every this pair of points, it is different and independent than the other. So you can change one line without changing the others. These are the line loops. They are not independent. Why? Because if you change this point, for example, it will change two lines. Okay, not just one line. So you start with one and you end at the same point, but in between there can be different line segments. The third one of a third type of line is line strip, and line strip are also continuous lines. The difference between these two, if you can see, is that the first and the last, for example, if you make a last one, they will be connected. Okay, so in line strip it is not connected, and in the line loop it becomes a loop or it becomes a closed shape. Then you have independent triangles, three independent points. You can move all the 3 points to change the shape of the triangle or any point, but it will only change the shape of one triangle. The triangle strip, it is what? You start the first triangle with 3 points, but after adding any one point, it will become a new triangle. And we will see all of them. Okay, then there is triangle fan. Okay, how does it work? We will see. Then there are independent quads. Quads means 4 vertices shape. Okay, so quads have 4 vertices. It can be a rectangle, it can be a square, or it can be any polygon with 4 vertices. Then you can have quads like this, quad strip, and a polygon has as many vertices as possible. Okay, so you can draw a polygon with 5 vertices, with 10 vertices, and so on, and it can have different shapes. Now, first thing is, when you want to draw something in OpenGL, you would set up a window. Okay, what type of window? So for example, this is one window, black window. You can see this is console. Okay, there can be some other window, but we want to draw something within the window on the screen. So for that, we will first we need to understand how to install, OpenGL. The setup I will upload, and you will see how to set up OpenGL. I will rather explain this at the end of this lecture. Okay, how to set up OpenGL, and then we include these two things: IO stream, okay, if we need that IO stream for cout, etc., and then glut.h. Okay, so depending upon the operating system, remember this point, maybe you add gl \glut, or maybe you just use glut.h. Okay, we will see in different examples where to use glut and where to use gl \glut.h. Okay, then we want to draw something on the screen, so we will have a function. You can give it any name. You can call it draw, you can call it draw line, or you can call it ABC. Okay, so give it a meaningful name that will draw something on the screen. And within the draw, what we did, we have just two GL functions. So they are OpenGL functions. The first one is GL clear, and the second one is GL flush. Okay, and they will be used in all drawing functions. Okay, so what do they do? The first one, GL clear, it clears the screen. Okay, if you remember clear rect, what we did in clear rect, we cleared a rectangular area. So when you say GL clear, it will clear the screen. And GL color buffer bit, it specifies that what type of we set the color of background, and it will set the clear color according to the background color that you specify. Okay, we will see the detailed example. Then there is GL flash, and the GL flash actually will be used after you have drawn something on the screen. So GL flash means that just finish all the drawing and draw it completely. Okay, so between GL clear and GL flash, you will do the drawing. So GL flash will be the last statement. Before GL flash and between GL clear, here you will have to draw something. Okay, draw points, draw lines, etc. Okay, now what we see in this draw function, there is no drawing. It just clears, okay, and then it actually flushes, means to flush something on this memory or show something on the screen. Okay, so after that there is another function which is init. Okay, and it can be anything. We call it init, which is for initialize, okay, to begin something, that is init, and this will actually define the window background color. Okay, this clear color will be actually what is used as here clear. So when you say here clear, it will be according to this color. Now 111 means what? Can anyone tell me? 111. So this is red, green, blue. 1 means full and 0 means 0, null. Okay, so 111 is equal to 255, 255, 255. Okay, which is like white, and 000 means black. So here we say that the clear color is white. What does that mean? That whenever I say here GL clear, so the complete window background will be white color. Okay, then you have GL ortho 2D. Okay, what is GL ortho 2D? This means that we want to use 2D function. Okay, and we will also see the GL ortho perspective, GL perspective, which is for 3D, but this means 2D function. And -2020, this shows how many pixels I want. Okay, so let's say a window is like this white area is, let's say, my window. Okay, so when I say -2020, it means that this point on the left, this will be -20, then 0 will be in the center, and that will be +20. Similarly, here that will be plus 20, this will be 0, y, and down this will be minus 20. So it depends on me how I define the coordinate system. If you don't define minus 20, 20, by default it will be minus 1 and 1. All is minus 1, 1, minus 1, 1. Okay, so it means that if 0 is your center and minus 1 is here, so between 0 and minus 1 in the middle, this will be minus 0.5. Okay, then minus 0.4, minus 0.3, minus 0.2, minus 0.1, and this will be 0, and so on. Okay, you can make it even, for example, 400, 400, let's say. Okay, 400 minus 400, but it depends on your application area, and we will see some examples. Okay, one thing is that 0. What is 0? This is the transparency. Okay, what is transparency? Shaffaf. Okay, so we will not use that. We will always keep that 0, which means that the background will be opaque color. Okay, very shaffaf. It will be just like pure black color or pure white color. Okay, um, but normally in some applications you may use it. Maybe we see some example. Okay, so what happened when we set up a window? We see that here are the ortho 2D, which has four parameters: x min, which is this side; x max, which is this side; y min, which is this side; and y max, which is this side. Okay, and we wrote it like this. Now this window is actually something like this. So there are 20 points. 0 is at center. Okay, and minus 20 because this is y minus 20 and this is x minus 20. This point will be minus 20 minus 20 and that point will be 20 20. Okay, this is how we define a window. Now those lines are just to show you that how will it look like, but actually the window will be something like this: just white window. After adding this minus 20 minus 20, you will be able to draw points at different positions. Now minus 20 minus 20 means that if you want to draw a point something like for example 5 5, so we will start from 0, then 1 2 3 4 5. Okay, and this x5, and similarly 1 2 3 4 5 on y-axis. So 5 5 will be this point, minus 5 minus 5 will be here. Okay, so that is actually your window coordinate system. Okay, there is an example of 10 7. So on x-axis we go 10 points, on y-axis we have 7 points, so this point is over 10 7. Okay, now once we have the window, okay, which is used for drawing, we will draw in another function, and we start with the main. Okay, the main function is the same C function. We will use the same C function main. Okay, and we will call the draw function from the main. We have already the draw function. We know how to draw something. Okay, so this is the main function, the same thing as we do in any C or C++ program. Okay, now the first thing we are going to do in main is initialize the glut system. Glut is the windowing system for OpenGL. So this is the same function glut init. It will have the same name, and we will pass these variables, which are argc and argv. They can be any variable names, but you need to pass exactly the same thing. So they are actually parameters for the glut initialization that you can pass through the command lines. Okay, but in this course we will stick to the same definition of main. It will remain the same, and glut init, it will remain the same. Okay, we will not change the definition of these two functions. Then after having glut init, we will have glut init display mode. Now you say that this is too many things, but don't worry about that, because there are two things. One, when you see the whole example together, then you will understand that okay, it's not difficult. The second thing is, normally I'm not going to ask you in the exam to write complete OpenGL program. Okay, you don't need to remember the order in general. Okay, but of course I will ask you in the exam about this function. For example, what is glut init window size function? What does it do? Or what is glut init display mode? Okay, what is this function, for example? Okay, so the purpose of function, or maybe I can give you the code which will contain all of these, and then you will say what does this code do. Okay, so you will explain the output of that. So here what we do is we will use a single buffer, and we have the option of double buffer. We will see later in the course. So we use single buffer, okay, and the RGB mode. Now at this point in the beginning, just remember this, that what does it mean to say GL edit display mode. How do they change? Don't worry about that. We don't care about it's working now, but it means that we want to say display set a display mode, and we have two options. We pass it single or double. Here we pass double, a single option, and we have RGB and some other types of display system. So we use just the RGB color model. Okay. Then we define the window size. Okay, in each window size, the initial window size is 600 by 600. Okay, so this is the number of pixels in x-axis and y-axis. If you use this 300 by 300, that will be a small window. Okay, 100 by 100 will be a very small window. 600 by 600, for example, let's say it will be half the screen. Let's say. Okay, then we define the window position. Okay, where do you want? 0 0 means that it will be on the top left, then 100 means 100 in this direction, okay, and 100 down. So this will be the top left of the window, and the 600 by 600 will be the size of the window. After that, finally we will create the window. Okay, so first we set the display mode, then we set the window size, then we set the window position, and finally we will actually create the window, and this will be the title of the window, whatever we want to be the title. So these four statements, they actually display the window. Before that, what we did in the last things, like here, okay, it will not work, these functions will not work if we don't call it. Okay, so after GL create window, we will see a window like this. Okay, this window you will see only after GL create window. Now we need to understand how does the window system work. Normally the display coordinate is from 0 0 to screen width and screen height. 0 0 is the top left corner of the display, and the screen width is the right bottom. We are talking about the screen. Okay, this is your monitor, for example. So your monitor is this, the blue one, and this one in the middle or at the position 100 this is our window. Okay, so it starts from 0 0. 100 means that move 100 in this direction and move 100 down direction, and 600 by 600 is the size of the window. So that is the system. Then finally, when we see a window, we will draw something on the screen. Okay, and whatever we draw, it is in the draw function. That was the very first thing. Okay, but we need to tell OpenGL what is our draw function. Okay, so we pass the name of our function, which is draw, to glut display func. Now what is glut display func? Glut display func means that OpenGL will use this function draw to display something on the screen, because OpenGL does not know how to display and what to display. Okay, so we will tell OpenGL to use the draw function, because our draw function will contain all the commands to draw something on the screen. Then we will have the same init function which we have here, okay, which we defined before, so that will be after that. And finally, this is the very final statement of glut main loop, which says that you continue doing this repeatedly again and again. Okay, so it will draw something, and then it will repeat that thing. It will call the draw function again and again. Now if there is just one image, it will keep refreshing the image again and again, or it depends. If you move the window, it will draw again. If you minimize the window and maximize the window, it will draw again. If you change the size of the window, it will draw again. Otherwise, it will just wait for any event. If there is any event, it will call the draw function. Okay. Now, what we see here is the complete OpenGL program that we have discussed. So the very first thing, we include the GL glut. Okay. Then we have the draw function. In the draw function, what we have is we have GL clear and GL flush. Okay. Now we write the whole draw function as a single line. Normally, it will be in 4 or 5 lines, but just to have the whole program on the single screen, we have this draw function in a single, and it works fine, because in C++, new line is not important, the space is not important. The important thing is semicolon. Okay, so with semicolon that will be one statement, then there will be another statement. So this is the draw function. It draws nothing, it will just have a white background. In the init function we choose the white background, okay, and this is the size of the our coordinate system. Then in the main we first initialize, then we have display mode, window size, window position, we create the window, we say what is our drawing function, we have an init, okay, and let main loop. And return 0 means that it will finish this, but it will only finish if the glut main loop exists. Because the glut main loop, it will continue forever. If you don't stop it, it will keep continuing. So that is glut main loop. Okay, now we know the basic OpenGL program. If you are able to run this, you will see a white screen. Okay, now we need to draw something on the white screen. All this code you see here is just like, you know, the command when we say ctx is equal to canvas.getContext. When we say canvas.getContext, what was there? We got a context. So now we have actually a context and we can draw something on the context. So it was very easy in the canvas that you have only one or two lines to have a canvas and then you just start drawing. But in OpenGL you need to do all these things. Okay. Now fortunately it's the same for every program. Okay, whatever program you do after this, it will be this same. We will use the same. If you want to change the window size, of course we can change here. If you want to change the window's position, we can change here. If you want to create a window with a different title, we can change here. Okay, if you want to display using a different function, for example, we say that my function is about drawing circle, I will call it draw circle. So I will say that my code is in draw circle. Okay, the init let main loop return, they will remain the same. The first line, the second line, they will remain the same. Okay, here it depends. If you want to change it to minus 2020 to something else, we can do that. Otherwise we will leave it like that. Okay, so once again, this complete program will just create a blank window, okay, with white background. It will not do anything. Now we want to add something to add something to it. Whatever we want to add, we'll see. So here we have OpenGL GL vertex DTV. This is a general definition of a, you know, how to have a vertex. Vertex DTV. What does that mean? So GL vertex is a function to have a vertex or a point on the screen, and it has three different versions. Okay, or many different versions, but it takes at three different forms. D means 2D or 3D. So you can have GL vertex 2 or GL vertex 3. 2 means it takes two dimensions, x and y only. 3 means it will take x, y and z. Similarly, T means for type. You can have integer, I, short, s, float and double. Okay, so you can have GL vertex 2i or GL vertex 3s, for example, or 3f, whatever. You have the combination of 2 and 3 with ISFD. Finally, V. V is optional for vector points. Vector points mean when you pass an array. If you want to pass an array as a function, all the points, then you will have the vector points. So that is also a form of the function, and we will explain this. So here are examples. GL vertex, for D we use 2 and for T we use I, and we don't use vector point but we give a single point 5 5. It means we have a two-dimensional vertex and it is in integer. Okay, the second one is two-dimensional in vertex but it is floating point. Okay, 5.5 6.3, this is float. Third one is three-dimensional with integer. Similarly, you can have three-dimensional with short, float, double, etc. Okay, and here we have an array. Okay, 2iv, so two-dimensional integer array. Okay, and the array we can specify, it will come in the next slide here. So how does it work, the array work? You see, if you want to draw a triangle which has three vertices, 0 0, 1 1 and 0 2, for example, Okay, so either we use the GL vertex 2i 3 times. So what we can use this GL vertex 2i 0 0, again GL vertex 2i like 2 2, and 0 vertex 3i 0 3, etc. Okay, so we can pass this 3 times, and every time it will represent a point. Or second way is you have an array of points, array which has 3 points. Okay, so this is point array. Point 0 is 0 0. Okay, this point. Point 1 is 1 1, and point 2 is 2 2. So I have 3 points as an array, and I will pass this array to vertex 2 iv. And remember, we will use GL begin and GL end before and after drawing anything. Okay, and when I say line loop, remember, okay, so GL begin what? What do you want to draw? So I want to draw a line loop, and line loop is what? It will connect the 3 points together. So that will give you a triangle. Another implementation you can see, instead of having 3 points and passing as a single array, we can define these 3 points separately: 0 0, 1 1, and 0 2. Okay, so both of the left and the right code, they will give you the same triangle. On the right side we have three different vertices, and on the left side we define 3 points as an array, and we pass the array to this function. The important thing to note here is the function type. So this is 2iv, which means we are passing a list of vertices. This is 2I, which means we are passing just a single point. Okay, about colors. How do you use color in OpenGL? Now, in color also we have 2 or 3 different types of functions to define color. Okay, so we need to set a color. If you don't set any color in the beginning, the default color is black. Okay, so it will draw something black on the screen, but we can change the color by using functions. So one function is GL color 3 UB. Okay, what is UB? It is unsigned byte. Unsigned byte. Okay, so we need a byte, which means that up to 8 bits, and in 8 bit we can have a value of what? From 0 to 255. So it means that the GL color 3B, it will take 3 parameters: red, green, and blue. It will take an unsigned byte which can take a value from 0 to 255. So 20 is for red, 150 is for green, and 170 is for blue. So there are some RGB interpret values like 0255 255. This is aqua color. Black is 000. Blue is 00255, and so on. Okay, so we already studied this thing in Canvas, and I hope you understand these. So in Canvas we also use the name, for example purple or red. Okay, but in OpenGL you cannot use names. You need to specify them in the form like this, 3 integers, unsigned bytes, and we will use these things. Or you can use any other color of your choice, for example 10 20 30, let's say. Okay, so that will give you a dark gray, greenish gray, etc. The second type of color function is colored 3f, which means 3 floating points. Okay, now instead of a range from 0 to 255, it will have a range from 0 to 1. Okay, so 255 will become 1, so 25500 will become 100. Okay, for red, GL color 3b is 0255, and for 3f it will be 01. Okay, now these functions, any one of them that you use, this function will be called before starting drawing on the object. Okay, so it will set the color to that, and then it will draw the color using that color which you specify. Okay, now we stop here because I need to discuss with you about the assignment. Any question from your side? No, Dr. Hadley. Okay, good. So I will just show you about the assignment. So the assignment says that you have 3 questions, okay, 10 marks, and you have to submit it by next Tuesday, 29th March. What you see is that you will use DDA algorithm and the Bressensham algorithm, and third one is the midpoint circle algorithm. Okay, so here you see how to fill the table for these 2 points: -3 -4 and 5 -3. you will draw a line between these 2 points. So what will be your K, what will be your PK, and what will be your next point. Maybe you use more than this, or maybe you use less than this. Okay, I just have a table randomly. You can use less or more rows according to your needs. Okay, so you will fill this for the DD algorithm, and you also need to fill a chart, this graph. Okay, so this is for DD algorithm. The next one is for Bressenham algorithm. You will find those K, PK, etc., and you will fill according to the Bressenham algorithm. The slides are there with you. The third one is about circle. So you will have a circle which will have a radius of 7 and centered at 5, 7. So how do you do that? I'm going to upload the slides if it's not already there, and I explain this how to draw a circle. Okay, finally, when you draw these tables, I have also given you an image, okay, a separate image, or I will upload it if I have not. So you will use it like this. So you have this graph paper, okay, and this is your 0 0. Okay, so this point is like your 1 1, and then 2 1, and 3 1, and 3 2, and 3 3, for example. Okay, so you will draw a pixel using what? Using this rectangle, then choosing same color. It's good to choose the same color. Okay, and then draw a rectangle here, and it will actually draw this thing for you. Okay, so this is actually your thing. Now I think I have not uploaded the graph. I will upload the graph soon, inshallah. Okay, that's one thing about the homework. Now the next thing is about setting up OpenGL. Okay, and that's very important that you set up OpenGL. Okay, so I'm going to upload OpenGL setup and running. One example is using Linux, okay, and the other one is using Windows. Okay, so this is installing Linux. Okay, if you want to install Linux, there are different instructions. I'm going to upload one. Look, you can use OpenGL in Windows with Visual Studio, or if you have Linux or you want to install Linux, then I give you also this option if you want to try Linux. Okay, so I give you option of how to install Linux operating system, and I gave you example of two operating system, Linux popular operating system, Ubuntu and Mint. Okay, so you can either download Ubuntu or Mint, and you have again two ways to install Linux. You can use a virtual machine. First you install a virtual machine, and then second way is the install the operating system completely in your hard disk. But I do not recommend this one. Remember, the C1 is not a good one. You can use VirtualBox, or you can use it to a USB or DVD, and then boot the computer from USB or DVD. For A and B options, they are good option. Okay. So for VirtualBox, let's say if you use VirtualBox, okay, and I said that I recommend to use this step if you have 4 GB or more memory. If you have less memory, then you should not use this because it will be very slow. Okay, so it's very simple. You have the video also here. Okay, you can follow this video on how to install operating system in VirtualBox, and there are also step-by-step instructions for Ubuntu and step-by-step instructions for Mint, and there is a video, so you can follow them to install if you want Linux. Okay, and the third, another option is you want to do it in Windows without installing Linux. Okay, so where is that? Just give me a minute, let me see. Okay, OpenGL setup, yeah. Okay, so OpenGL setup in Windows. Okay, you need to install Visual Studio. Okay, you need to have Visual Studio, and then once you have the Visual Studio, any version, but here I have the example of Visual C++ 2019 Visual Studio, and you need to download the free version of Visual Studio, okay, which is I think Visual Studio Community, yeah, Community Edition, not the other one, not the developer one, the Community Edition. So once you install the Community Edition, then you can set up the library. You can download the GLUT from glut file from here, this zip file. Then you can also download it from here. Okay, so this will take you to this link, or this is the direct zip file link. Download the zip file, or I can also provide the zip file. I will upload the zip file to you. Okay, you just have the zip file with you. Okay, it will be in the LMS. So when you download it, then you will see this in the zip file, 5 different files. You need these 3 files to set up Visual Studio. What we want to do is to set up Visual Studio to use OpenGL. Okay, so how do you set up? You will use these 3 files and you will put them in these directories I have told you. You will put glut32.dll, which is this one, in C Windows system here. Okay, you will use the glut.h or glut32.h, whatever it is. You will use it in this folder, include, and finally you have glut32.lib. Okay, the lib file which you will use in this direction. Okay, so now when you copy all these files in these folders, then your library will be set up. Now let me show you that, for example, how did I do. So I will open this, and in C Windows, C, where did I say, if you see the first one is C Windows System 32, C Windows System 32, and here I have the glut32 DLL. Okay, there is also OpenGL32 DLL, but anyways, forget that. There is glut32 DLL, which I put in C Windows System 32. The next file is about glut-h. Okay, glut-h is in this folder, C program files, Microsoft Visual Studio 2019. Okay, so you can go there, CD program files, etc., to this folder. Maybe the version is different, so you will have a different versions. Okay, because for me the version was 14 point something, so maybe you have a different version, so that folder may be different, but at the end in MSVC you will have the include folder, so you copy that in the include folder. Okay, and the other one is here. Now finally, once you have set up Visual Studio, open Visual Studio, create a new project of type console app. So you will have a new project and then choose console app. Okay, and from the console app, click on the next button, and then you give some names, for example OpenGL test, and then where you want to save it, for example. Okay, and after that, when you do the create, it will create a project and copy this code in the slide. From the slide, copy this code. Okay, and you click on run the project. So this is the empty screen you will see. Okay, just empty screen without anything. So if you achieve this thing, it means that your OpenGL is working fine, and you have this as an assignment. Okay, so that has 5 marks and you have to upload this. I will give you the homework. Any questions?